Now we will go through a brief understanding of eigenvalues and eigenvectors. So we will be using this concept here. If you consider a matrix P, okay, then lambda P is equal to AP, where lambda is a scalar and A is a matrix. Okay, here what is happening, this matrix P is being multiplied by a scalar, but the effect of multiplication by a scalar is similar to the effect of multiplying that matrix P with another matrix A. Okay, such a condition is of importance to us. Here the matrix P is called as the eigenvector of A and lambda is the eigenvalue. Now if a matrix A is given, then how do you find its eigenvalues and eigenvectors? So first we will go ahead with the eigenvalue. So this equation, if you take lambda P is equal to AP, then how you can write this? Lambda P minus AP is equal to 0. Now P you can take out common, so you can write this as lambda into I. I is the identity matrix, minus A, P is equal to 0. So now P here is not a 0 matrix, right? So the only condition is that this is 0. So we get determinant of lambda I minus A is equal to 0. Okay. So this equation, from this equation you are going to get the eigenvalue lambda. Next, how will you get the eigenvector? Once you get the eigenvalue lambda, then you use this equation lambda I minus A into P is equal to 0. Now you know lambda, so lambda I minus A you will know. From this equation you can get the eigenvector P. Okay, so that is how you find the eigenvalues and eigenvectors of a matrix